So today we'll be making some simple applications because I think a lot of you haven't done Java before. And Java is like a full-blown programming language. So this is going to be stuff that like even adults sometimes don't know. So we're going to get started by creating these three initial blocks: global variables, void set, and void draw. The way to get these is you go to the global section, and then we're going to drag these blocks out into the code area. One of you said, what if I grab something that I didn't want? Like let's say I grabbed this void mouse pressed. The way to delete something is to drag it all the way to the left side and then let go. Okay, so the first thing we're going to actually learn about is how to set the background color. So whenever you're making any kind of app, you want to display some kind of background color, and we're going to select the background block and put it into what's called the void draw. So background here has 3 numbers, and we can even like put our mouse a little bit over the number and click on it to be able to change it. Color in a computer is usually specified by 3 primary colors. Who here has heard of primary colors before? Okay, some of you have. Red, yellow, and blue. So if you've been doing painting, you're going to use red, yellow, and blue. But actually, computers are a little bit different from when you're painting because computers give off light while paints make things darker. So when you use what are called additive colors, you don't use red, yellow, and blue. It's red, something else, and blue. Has anyone heard of red, green, and blue?
Yeah.
Yeah, RGB. So let's try changing the numbers to 0, 2, 5, 5, 0, like this. Okay? And we're going to then click on the Run button to run our program. Yep.
Green.
Green. That's exactly it.
Try changing it to red. How will you do red? Anyone have any ideas? Any guesses? So 0, 2, 5, 5, 0 is green.
225, then 0, 0.
Yeah. You make the first number big, like 255, for example.
Very good.
And then make the next 2 numbers small. And then when you click on the Run button, it'll make it red. The first number is how red it is, the second number is how green it is, and the third number is how blue it is. Thank you to the audience programmer there. Okay? So you can mix and match colors to get any kind of color you want. We're going to move on now, and we're going to draw a shape. I want to draw an ellipse. Leon. Okay, Leon, you found the shape. Where is it? Where did you have to click first? Shapes. Awesome. And then where did you click after that? Ellipse, right? Okay, so it's the third one. So we're going to drag the ellipse underneath the background. Go ahead and add the ellipse into the background. Okay, and then you can run the program, and it's going to be drawing an ellipse. So now we're going to try some new stuff, but this time I'm going to have you figure it out by working with a partner. So, hey, this is a good question. What happens if I accidentally delete something important? Well, there's a few ways. Like I just deleted the container that holds the number block. So if I accidentally delete something like this, how do I get it back? Well, the hard way is to try to find the block on the left side, but there's an easier way called undo. And on a Windows computer, which you guys are kind of using, or a PC, it's not Windows, but these are PCs. On a PC, undo is Control-Z. Okay, so we learned now that the first number controls the left-right position. Sometimes we'll use the fancy term, the X position. You girls got it? The second one controls the what position? Yes, which is also known as the, not the X, but the, it's called the Y position. Yeah, and then the third number, don't worry, I'm just trying to figure out what you guys already know. The third number controls the width, and the fourth number controls the height. Great. Let's also, just for me, you don't have to do this, but I'm going to make the ball red by adding this fill block. You don't have to do it, but I just want to do it because it's hard to see this if you're far away from the screen without making it red. Okay, so great. Now we have a red ball. And I want to now talk about something really advanced, but really powerful, called a variable. Do you guys understand that computers are just dumb machines? So they can really only do 2 things. They can hold numbers, and they can make calculations on those numbers. That's it. Every single movie, CGI you've ever watched, self-driving car, your phone, I don't know, maybe you got like little gadgets other stuff at home, right? All those things, all they can do is math. So computers are just big math machines, right? And so the really cool thing about math is you can represent anything as information. And we're going to start by moving this ball by representing its location as a piece of information. I'm going to go to variables. I want you to go to variables. And we're going to grab that first block called integer x equals 10. And we're going to put it into the global variable section. This variable, you can imagine as an invisible box in the computer. And in the box, we can put a number. Okay? So you can put the number 1 or 2 or 5 or 10 or even like over 9,000, like 10,000 or something like that. We create that block. And then I'm going to add two things. I'm going to, first of all, change the ellipse, the first number to x. We'll change that first number to x. Okay? Awesome. Great job, students. And then the next thing is I'm going to grab this variable block that's a little bit down. You have to scroll down. Yeah, and then we're going to grab the x equals x plus 1 block and put it there. So we have to do two things. Change the first thing to x, and then add x equals x plus 1. I'm going to run it, and you'll kind of see what the resulting behavior is.
So here, do you guys help? It's gonna move.
Okay, so it's moving, and it's moving right. Okay. So in the beginning, x is a variable, so you can think of it as a box. And I put 10 in the box because at the top it says x equals 10. Okay? And then what void draw does, everyone look at me, this section here is called void draw, is it runs 60 times a second. And what we're going to do is this, we're going to change x to be bigger and bigger and bigger. How? Well, x equals x plus 1 means take x plus 1. What's 10 plus 1, guys? What's 10 plus 1? 11. And put it to x. But the next time, it's going to say, what's x plus 1? What's 11 plus 1? 13, right? And 14, and then 15, and then 16. So x equals x plus 1, every 60 times a second, it makes x bigger. And then the ellipse line, what it does is it draws the ellipse where the x position, where the left-right position, what you two girls figured out, that's controlled by x. So because x is getting bigger, and because you're drawing the ellipse where x is, it looks like it's moving right. And so one of you guys asked the amazing question, how do we make it move left? That's tricky. Okay, yes?
You can set x to like a different point, and then you do x equals x minus 1.
Ah, just 1 minus, but yes.
Minus 1.
Yeah. So if you make a number bigger, it's going to move it right. And if you make the number smaller, it's going to move it left. So let's try x equals x minus 1. And then I think the student made an astute observation, which is that because we're starting on the left side, it's going to look like it's moving left, and it's going to go off the screen really fast. So you might want x to start at a bigger number. So for example, if you start x at 600, it'll be a little bit more fun. So I changed it to x equals 600, and I also made it x equals x minus 1. The last thing I want us to code, because we're running out of time, and I want to show you some cool games before you leave, and also some art maybe even, is I want to ask you guys how to make it move faster. So right now it's like 10, 9, 8, 7, 6. How can we make it go faster? Right now it's like x equals x minus 1, so it's 10. I want someone else to answer. I know, you did such a good job. 10, then 9, then 8, then 7, then 6, then 5. How can we make it look like it's moving faster? One of you said you have to put a bigger number to subtract. You want to do x equals x minus like 5, or x equals x minus like 10. If you make it too big, it's just going to fly off the screen before you.
I know, that's what it's fun about. What do you do?
Okay, so I'm going to do x equals x minus 5.
So, where's the x?
Uh-huh. Oh my gosh, x equals x minus 100. You'll see it for only a sixth of a second. Okay.
How much
That's like 167 milliseconds.
How much balls do you see?
Okay. Okay, so we're pretty much out of time, and the last thing I want you to do is to show you how to play other people's games. I want to talk a little bit how to make more complicated applications. So you guys have been programming Javablocks, but as you notice on my screen, that actually changes the code in the center. And that's like how older kids, because some of you are like 8 or 9, that's how when you're like maybe 10 or 11 or 12 or 13, you start programming by typing it. And so I want to start showing you processing, just programming in this code. But rather than just coding, because it's going to take a long time to type some stuff, I want to show you some games. When you're on our website, there's a page called Projects. And on the Projects page, there's lots of apps, and some of them are games. You don't need to do this because I'm just demonstrating. I'll click on the second game and click on the View Code. So the cool thing is that every single game on the website is open source. That means you can see what that student made to write the code. And so all I need to do is copy the code and then paste it in the coder in processing, and that allows me to play that game. So in this case, this game called Circumvent by one of our students is a game where you have to click, and when you eat the smaller circles, you get to pass the next level. But then if I click toward one of the bigger circles, then I die. And actually, pretty much, that's pretty much the game for me, which is dying all the time. It's pretty hard. So as you can see, it's pretty amazing because like this code that you see on the left is this game. And there's all sorts of games you can make. Like you can make shooter games, you can make role-playing games, you can make puzzles. Because you know, every single application that anyone's ever made is programmed. The last thing I want to show you is some of like the art that I was working on earlier today and yesterday. So even though some of you maybe are like, oh, I really want to make a game, some of you might be like, hey, I don't really want to make a game. Maybe you want to do something different. Maybe I want to make Harry Potter look like he's made out of worms. Or maybe I want to make something that looks like a piece of modern art. Okay? Like this thing. This thing is called a branching fractal. You can see as I move my mouse. Okay?
You guys see the screen?
And so when you learn programming, you not only get to write code and not only get to play other people's apps, but you also get to see how more and more complicated things get made. Okay? That's going to give you a lot of power as you get older and older and more good, especially better typing. It's going to give you lots and lots of abilities. Okay. Any final questions from these young students before we finish off? Yes.